right, so now we're going to talk about cycloalkanes. So cycloalkanes are very similar to the linear ones, except they're in ring shape. So they're going to form, like you're seeing on the screen now, something like a hexagon or a square or a triangle, some type of geometric shape where all of the carbons are connected to each other. In more sophisticated ones, which we're not really going to look at, you can also sometimes see where you have multiple rings fused together. But again, we're not going to look at anything like that in this class. So cycloalkanes have the formula of CnH2n, which is a little bit different than alkanes, which if you remember, they had alkanes were CnH2n plus 2. So the difference there is that plus 2, and the reason that the cycloalkanes don't have the plus 2 is if you look at their structure, there's nowhere where it's just kind of hanging off the end like a cap, like we talked about with the alkanes. So these ring ones don't have a cap. So basically, if you look at this cyclohexane molecule here, everything is a CH2, right? There's no CH3s anywhere in that structure. So because of that, the formula is going to be CnH2n. So here are a couple examples. So cyclopropane, cyclobutane. So again, you're going to take the parent chain that tells you how many carbons are in the structure, and you add cyclo in front of it. And we'll look a little bit more at the naming here in just a minute, but these are the basic ones, right? Cyclopentane and cyclohexane. Notice if you look at the ball and stick models above, you can see that all of the carbons, which are in black, are going to be attached to 2 hydrogens. Okay, so naming the cycloalkanes. So we're going to follow a lot of the same rules before. The big exception here is we're going to see the word cyclo in there to tell us that there's a ring present. So we're going to have a prefix that talks about the substituents, cyclo, and then the parent, instead of the parent chain, is going to be the parent ring, right? So cyclohexane would be a 6-membered ring, and then a suffix if there's any functional groups, which for right now we're not going to worry about in any of our structures. So all of the ones we're talking about here in this chapter are going to end in ane, right? Because they're all alkanes. All right, so here's kind of the summary of everything we need to do in terms of naming a cycloalkane. So step 1 is going to be find the parent cycloalkane, and then we're going to name and number the substituents. Now the one problem here, or not really a problem, the one thing that's a little bit different than the acyclic alkanes is that the numbering of the substituents is difficult whenever you're talking about a ring. So if you imagine looking at a circle, like it's impossible to tell where that circle starts and finishes. So because of that, there's some separate rules for cycloalkanes that we need to talk about. So the first one there is that no number is needed for a cycloalkane with a single substituent, right? So if you only have one substituent, so looking at the methyl cyclohexane that we see here, right, the methyl cyclohexane, that has a methyl group, which is that CH3 attached to cyclohexane. We can't say it's on carbon 1, 2, 3, 4, 5, or 6, because you could imagine rotating that thing around and it can occupy any of those positions. So the short of this is whenever there's only a single substituent, we do not put a number and we just say methyl cyclohexane. So in that case, you don't number the substituents. If you have 2 substituents or more, then you do need to number them. So that brings us to the next bullet point, which says that for 2 different substituents, you're going to number the ring to assign the lower number of the substituents alphabetically. What this means is that if you have something, whoops, let's go to this one. So you have something like this, right? You have an ethyl group and a methyl group, right? So we look up here, this one is ethyl, this one down here is methyl. So we know that we want to give them the lowest possible numbers, right? So we know we're going to want it to be 1 and a 3 because one of the things with doing the numbers, let me go back here a second. The last bullet point here says that for more than two substituents, or even for two substituents for that matter. You're going to number the ring so that the sum of the numbers is as low as possible. So in this case, we need to have our groups at 1 and 3 because that's going to give us the lowest sum of those numbers, right? If we put them at 2 and 4 or 3 and 5, right? Anything where they're 2 apart, it's going to be a bigger number than 1 and 3. So you're always going to have a substituent at number 1, and then the rest of the substituents will fall in from there. So in this case, how do we determine if the ethyl is going to be the 1 or the methyl is going to be 1? Alphabetical order. Earlier letter, lower number. So ethyl goes before methyl. So this one would be 1-ethyl 3-methyl cyclohexane. All right, so now let's go back. And so basically we're going to one single substituent, no numbers, 2 or more substituents. We're going to give the lowest possible number around the ring, and we're going to put the substituents alphabetically whenever we name them. So again, in terms of lowest numbers, this is going to be 1,3 dimethyl cyclohexane. You could imagine, I'm going to go to a green marker here. You could also imagine if we called out 1, 2, 3, 4. Right, we could also, in theory, number our carbons going counterclockwise the other way. We would not want to call that 1,5 dimethyl cyclohexane. And for that matter, just to make a point, we could call this carbon 1 and then 2, 3, 4, 5, 6. So it doesn't matter which substituent you start at. Whenever they're both the same substituent, you're going to end up with the same name. So this one would also be 1,3-dimethyl cyclohexane, whether you number it using the numbers I wrote in green or the numbers that were already on the slide. They both give you the same thing at the end. Okay, so let's do a couple practice problems here and just practice naming these. So for this one, the first thing we're going to do is the parent chain. So this parent ring has 3 carbons. That's going to be cyclopropane, right? So cyclopropane takes care of that part that's circled. So now we need to look at the substituents. So the substituents are in the clouds here, right? And those are all methyls. So every single one of them is a methyl group. So we're going to have trimethyl, but we also need to number them. Now, every single methyl needs a number. So even though 2 of them are both attached to that carbon right there, they both still need their own number. So we need 3 numbers. And what we're going to do is call this 1, 1, and 2, because that would add up to a total of 4. Right? If we were to go around counterclockwise, we could also have 1, 1, and 3, and that would be a higher number. An incorrect numbering is going to be in green here. Like if I did this as 1, and up there is 2, and over there is 3, and I did 1, 2, 2 trimethyl, that would also be wrong. So again, we're going to stick with the red numbers. I'll go ahead and erase the green ones here. Okay, and our final answer would be 1, 1, 2 trimethyl cyclopropane. So again, remember, anytime you see a prefix like tri, you need to make sure you have 3 numbers there. Okay, so let's move on to the next one. So again, the parent ring in this case is going to be a 6-membered ring. So this one's going to be cyclohexane. And now if we look at the substituents, right here in blue, we have a CH3, a CH3, and then a CH2CH3. That one's an ethyl, and both of those are methyl. So now we want to go through and figure out how we're going to number those methyls and that ethyl to give it the lowest possible number. And again, what you really want to do is just do some trial and error. After you do some practices, you'll be able to better see it quickly, but we're going to start here. 1, 2, 3, 4, 5, and 6. So if you look at the substituents, we have 1 on 1, another on 2, and on 4. So we have kind of 1 plus 2 plus 4. That would equal 7. So another way to do it, I'll number again, this time in black. So I could start down here where the ethyl group is. I'm going to put that as a 1, 2, 3, 4, 5, and 6. So this time my substituents would be a position 1, 3, and 4, which would be 8. Well, we don't want that. And no matter what else we do, the lowest one is going to be 7 in this case. So that's the one we're going to use. So that gives us, using the green numbers, so I'll go ahead and again erase the black numbers best I can here. All right. So now we have a 1, a 2, and a 4. So how do we number them? Well, remember, whenever you have two different substituents, in this case methyls and ethyls, we go in alphabetical order. So ethyl is going to come before methyl. So in this case, it's going to be 4 ethyl, 1, 2 dimethyl cyclohexane. So again, a little bit confusing in terms of making sure that you follow all of the rules. Once you understand these rules, if you apply the rules, you'll always get to the right answer. So that's a long name, right? 4 ethyl, 1, 2 dimethyl cyclohexane, but that's our final answer here. Okay, so one more for now for naming the cycloalkanes, and that one is going to be a parent chain that has 4, so cyclobutane. And now this one, I intentionally put this on here a little bit different. It's all the skeletal structure, so that's going to be a substituent, and that's going to be a substituent. A 1 carbon substituent, here that's the same thing as a methyl, that's the same thing as a CH3. A 2 carbon substituent, as we see on the bottom, that's going to be the same thing as an ethyl. Okay, so in this case, it gets a little bit tricky in that we can call this 1 and 2 in blue, or we could go in black, in green here and go 1 and 2. Either way, whenever we number those two, they're going to add up to 3. So how do we know which one gets the 1? Do we put the 1 on methyl, or do we put the 1 on ethyl? Well, when in a situation like this, the lower number goes alphabetically, so it's going to go to the ethyl. So we're going to use the green numbers, and our final answer here would be 1 ethyl, 2 methyl cyclobutane. All right, so that's kind of how you go about naming cycloalkanes. Now, the last thing I want to show in this video is, well, actually 2 more things. We're going to draw a couple cycloalkanes here, and then we're going to do a couple problems that involve correcting names that are wrong, and I'll show you what that means on the next slide. So for this one, propyl cyclopentane, work backwards, right? Cyclopentane means a 5-membered ring, so we're going to draw a pentagon. Propyl cyclopentane, propyl means 3, and in this case it doesn't give us a number. Remember, you don't need a number if there's only 1 substituent, so we can draw it anywhere we want. And I'm just going to draw the skeletal structure. Actually, I'll draw them both for you guys. So that one would be the skeletal structure that has a 3-carbon substituent. I could also draw it like this. That's a really bad pentagon. Let me erase and try again. I like that one better. CH2, CH2, CH3. Those two are exactly the same, right? So both of those are propyl cyclopentane. 1,2-dimethyl cyclobutane. So again, looking at the parent chain, cyclobutane. Butane is 4. That's going to be our square. 1,2-dimethyl, 1 and 2, or methyl, methyl. So both of those are correct ways of representing it. All right, so now, why are the following names wrong? So these are problems like you'll see in a few in your book, and these ones I think are good practice because what you have to do is it's telling you that 4-methylpentane is a wrong name, but without knowing it without just looking at it, you probably can't figure it out. So what you have to do is draw 4-methylpentane knowing it's wrong. So we're going to draw this one. Notice this one, the parent chain is pentane. So this is back to not a cyclo one. This is just regular old pentane. So 4-methylpentane. So that's pentane, and we're going to have a methyl group on carbon 4. So then you have to, once you have that drawn, you kind of have to erase your brain and not even think of 4-methylpentane anymore. And you come down to this structure that you've drawn, and we want to rename it. So we want to rename it basically counting the number of carbons in the parent chain. One thing that's often wrong with these is how many carbons are in the parent chain. That's actually not the case in this one, as we'll see. 1, 2, 3, 4, 5. So it's still 5. So it's still going to be pentane. And then the substituent is going to be up there. So it still looks like it's 4-methylpentane, right? Because this one here is a methyl group. But you have to remember that we can number these things going in either direction, right? 1, 2, 3, 4, and 5. And we want to give the substituent the lowest possible number. So instead of 4-methylpentane, it should really be 2-methylpentane, right? So that would be the correct answer for that one. The next one on the bottom, 1,3-dimethylpentane. There's our pentane again. We draw a methyl on carbon 1. 1, 2, 3, 4, 5. Then a methyl on carbon 3. Now you have to, once we've done that, you kind of have to erase the name because you don't want to think about that one anymore or it'll mess you up. Take away those numbers because what you'll see is if we actually go to number this, the parent chain is really 1, 2, 3, 4, 5, 6. So we actually have a hexane here with a substituent, a methyl group right there. Now, before we say it's 4-methylhexane, the other thing we need to do is make sure that if we number it going the other direction, we don't get a lower number, which, as you can see, we did. So this one would be 3-methylhexane. All right, so now let's do the same thing with a couple cycloalkanes, 1-methylcyclopentane. All right, so again, the parent chain being cyclopentane, that's going to be our pentagon. 1-methyl, like that. The trick on this one is remembering that whenever you have only one substituent, you don't need a number. So the answer to that one is simply methylcyclopentane. And then the last one here is cyclohexane, so that's going to be a 6-membered ring. That's our hexagon. We want 1, and I'll put the methyl as a CH3 this time, and then 3, and then 3. So 1,3,3-trimethylcyclohexane is what I have drawn. Now I'm going to erase that name because we know it's wrong. And I think what you can hopefully see here, well, we know that it's wrong if we go with the 1, 3, 3. So let's try it differently. Let's do 1, 2, 3, 4, 5, 6. And what you'll see here is if we add up the total number of our substituents, we have 1 on 1, another on 1, and 1 on 3. So that would add up to 5, right? 1 plus 1 plus 3 is equal to 5. Whereas in the original one, they added up to 7. It's bad. So we want to go to the one that adds up to 5. So this should still be 1, 1, 3. Trimethyl cyclohexane. All right, so again, whenever you have a problem that says why are the names wrong, draw them out as it's written, kind of erase your brain from that particular name, and then try naming it again following the rules.